So the first thing the author needs to do is to make a selection of what is worth presenting. Having decided that, he or she will need to convey the message effectively using a mixture of text, tables, and graphics. The level of details required depends a great deal on the target audience of the paper. Data research. Any information that has been collected, observed, generated, or created to validate research findings. The forms of data are not limited to electronic data of today. It may also include non-digital formats as well as notes and journals. Research data takes many different forms. Data may be intangible, as in measured numerical values found in a spreadsheet, or an object, as in physical research materials such as samples of rocks, plants, or insects. Here are some formats that research data can take: content analysis, spreadsheets, video, computations, research, field notes, data, photo, and others. This is to differentiate qualitative as against quantitative data. Qualitative data often used for exploring. It helps researchers gain an understanding of underlying reasons, opinions, and motivations. It also provides insights into the problem or helps to develop ideas or hypotheses for potential quantitative research. Using qualitative research methods, the sample size is typically small and respondents are selected to fulfill a given quota. On the other hand, quantitative data is used to quantify the problem by way of generating numerical data that can be transformed into usable statistics. It is used to quantify attitudes, opinions, behaviors, and other defined variables and generalize results from a larger sample population. Quantitative research uses measurable data derived from measuring instruments to formulate facts and uncover patterns in research. Here are some of the key differences in terms of the actual data. Qualitative data is not countable. It is chunks of text, photos, videos, and so on. Quantitative data can be counted as it is numerical. Qualitative data is usually unstructured, which means it's not ordered or grouped logically. You can turn qualitative data into structured quantitative data through analysis methods. Most of the time, qualitative data will be collected from a smaller sample size than quantitative data because generally you're not looking for statistical significance with qualitative research. Qualitative data is quite rich and it can give you directional insight about people's thoughts, feelings, emotions, and so on. Last is quantitative data can help to give you more confidence about a trend and allow you to derive numerical facts. Research data sources. Primary data analysis, in which the same research individual or team of researchers designs, collects, and analyzes the data for the purpose of answering the research question. Whereas secondary are existing data collected for another purposes that you use to answer your research question. So aspects of secondary sources. The study design and data collection are already completed. Data may not facilitate particular research question or information regarding the study design and data collection procedures may be scarce. Data may potentially lack depth, so the greater the breadth, the harder it is to measure any one construct in depth. Certain fields or departments, like experimental programs, may place less value on secondary data analysis. Last, often require special techniques to analyze statistically the data. Here are the advantages of primary as against secondary data. So advantages to using primary data: you collect exactly the data elements that you need to answer your research question. You can test an intervention, such as an experimental drug or an educational program, in the purest way. This is an example of double-blind, randomized controlled trial. You control the data collection process so you can ensure data quality, you minimize the number of missing values, and you assess the reliability of your instruments. On the other hand, these are the advantages of working with secondary data. So you get large samples, you can provide population estimates. This is less expensive to collect than primary data, and it takes less time to collect secondary data, and you may not need to worry about informed consent or human subjects restriction. In the succeeding slides, I'll be discussing about research data types. So number one, observational data. These are captured as it occurs, irreplaceable unless recorded, non-reproducible, and examples of which are imaging results like X-rays, and data captured by sensors like noise, pollution, and light levels. Number two, experimental data. Experimental data are collected through active intervention by the researcher to produce and measure change or to create difference when a variable is altered. Experimental data typically allows the researcher to determine a causal relationship and is typically projectable to a larger population. So this type of data are all often reproducible, but it often can be expensive to do so. Number three, simulation data. These are generated by imitating the operation of a real-world process or system over time using computer test models. For example, to predict weather conditions, economic models, chemical reactions, or seismic activity. This method is used to try to determine what would or could happen under certain conditions. The test model used is often as or even more important than the data generated from the simulation. Number four, derived or compiled data. So derived data involves using existing data points, often from different data sources, to create new data through some sort of transformation, such as arithmetic formula or aggregation. For example, combining area and population data from the Metro Manila and 5 neighboring provinces to create population density data. While this type of data can usually be replaced if lost, it may be very time-consuming and possibly expensive to do so. Five, or last one, is reference or canonical data. These are captured as it occurs, irreplaceable unless recorded. So examples are imaging results like X-rays and data captured by sensors. Presentation of data. This refers to the organization of data into tables, graphs, or charts, so that logical and statistical conclusions can be derived from the collected measurements. Number one, presentation of data is very important in delivering your message to the readers of your research. Number two, it has to be pleasing to the eyes to grab the attention of the readers. Text, tables, and graphs for data and information presentation are very powerful communication tools. They can make an article easy to understand, attract and sustain the interest of readers, and efficiently present large amounts of complex information. Data, gathered information, can be presented in many different ways to help make it easier to understand and more interesting to read. Displaying data visually with pictures can make it easier to understand. It makes the information stand out on the page. So number one, keep it simple. This golden rule seems obvious, but authors who have immersed in their data sometimes fail to realize that readers are lost in the mass of data they are a little too keen to present. Present too much information tends to cloud the most pertinent facts that we wish to convey. 2. First general, then specific. Start with response rate and description of research participants. This information gives the readers an idea of the representativeness of the research data, then the key findings and relevant statistical analysis. Data should answer the research questions identified earlier. Leave the process of data collection to the methods section. Do not include any discussion. These errors are surprising quite common. Always use past tense in describing results. Last, text, tables, or graphics. These complement each other in providing clear reporting of research findings. Do not repeat the same information in more than one format. Select the best method to convey the message. There are three methods of presentation: textual, data tables, and diagrammatic. In textual presentation, consider these two lines. Mean baseline HbA1c of 73 diabetic patients before intervention was 8.9%, and mean HbA1c after intervention was 7.8%. HbA1c, by the way, is the average glucose level within a span of 3 months. Mean HbA1c of 73 diabetic patients decreased from 8.9% to 7.8% after an intervention. In line 1, the author presents only the data, what exactly was found in a study, but the reader is forced to analyze and draw their own conclusion. Meaning HbA1c decreased, thus making the result more difficult to read. Whereas in line 2, the preferred way of writing, the data was presented together with its interpretation. Data, which often are numbers and figures, are better presented in tables and graphics, while the interpretation are better stated in text. By doing so, we do not need to repeat the values of HbA1c in the text, which will be illustrated in tables or graphics, and we can interpret the data for the readers. However, if there are too few variables, the data can be easily described in a simple sentence including its interpretation. For example, the majority of the diabetic patients enrolled in the study were male, comprising of 80% compared to the female, which is about 20%. Here are redundant. The exact values in the data will show just how remarkable, how extreme, and how obvious the findings are. Let the data speak for itself. Example, it is clearly evident from figure XX that there was a significant difference in HbA1c level at 6, 12, and 18 months after diabetic self-management program between 96 patients in intervention group and 101 patients in control group, but no difference seen from 24 months onwards. This explanation is made too wordy. So it can be improved by rewording it as follows. Statistical significant difference was only observed at 6, 12, and 18 months after diabetic self-management program between intervention and control group. The p-values and numbers of patients are already presented in figure XX and need not be repeated. Remember to avoid redundant words and information. Do not repeat the result within the text, tables, and figures. Well-constructed tables and graphics should be self-explanatory. Thus, detailed explanation in the text is not required. Only important points and results need to be highlighted in the text. Parts of a data table are as follows: title, body, rows, and columns. In making title, keep in mind to make it brief and relate clearly the content of the table. Words in the title should represent and summarize variables used in the columns and rows rather than repeating columns and rows titles. For example, comparing baseline waist circumference, HbA1c, blood pressure, and LDL cholesterol level among Malay, Chinese, Indian, and other races is too wordy and redundant. It can be improved by changing it to comparing baseline diabetic metabolic control among different races, which is clearer and simpler. Columns and rows. Columns are vertically listed data and rows are horizontally listed data. Similar data ought to be presented in columns. Often, these are dependent variables and allow clearer comparison among groups. Let's compare table 1A and 1B. The dependent variables in table 1B are waist circumference, HbA1c, SBP, and etc. Table 1B, on the other hand, shows a better comparison of dependent variables among ethnicity than table 1A. The first column to the left is usually a list of its independent variables like Malay, Chinese, Indian, and others. As the example of table 1B, a table with too many dependent variables would become too wide for a page. There are two alternatives to this problem. We can list the dependent variables in the first left column and independent variables across the top. However, doing so should not compromise clarity of the message we want to get across. The second alternative is to use abbreviations which can be replaced by footnotes explaining their definition. Body of the table. We can improve the clarity of data presented in body of the tables by the following. One is consistent use of units and its decimal places. Look at the data on systolic blood pressure in Table 1B. It is neater than the similar data in Table 1A. Arrange date and timing from left to the right. Round off the numbers to fewest decimal places possible to convey meaningful precision. Mean systolic blood pressure of 165.1 millimeter mercury in Table 1B does not add much precision compared to 165 millimeter mercury. Furthermore, zero point 0.1 millimeter mercury does not add any clinical importance. Thus, blood pressure is best to round off to the nearest 1 millimeter mercury. Next is avoid listing numerous zeros, which made comparison incomprehensible. For example, total white cell count is best represented with 11.3 by 10 to the 6th power per liter rather than 11,300,000 per liter. This way, we only need to write 11.3 in the cell of the table. Also, avoid too many lines in a table. Often, it is sufficient to just have three horizontal lines in a table, one below the title, one dividing the column titles and data, and one dividing the data and footnotes. Vertical lines are not necessary. It will only make a table more difficult to read. You compare tables 1A and 1B. Standard deviation can be added to show precision of the data in our table. Placement of standard deviation can be difficult to decide. If we place the standard deviation at the side of our data, it allows clear comparison when we read down. On the other hand, if we place the standard deviation below our data, it makes comparison across columns easier. Hence, we should decide what we want the readers to compare. Put However, presenting numerical presentation is through graphics or the diagrammatic. Graphics are particularly good for demonstrating a trend in the data that would not be apparent in tables. It provides visual emphasis and avoids lengthy text description. However, presenting numerical data in form of graphs will lose details of its precise values, which tables are able to provide. The authors have to decide the best format of getting the intended message across. Is it for data precision or emphasis on a particular trend and pattern? Likewise, if the data is easily described in text, then text will be the preferred method, as it is more costly to print graphics than text. For example, having a nicely drawn age histogram takes up lots of space but carries little extra information. Since graphics should be self-explanatory, all information provided has to be clear. A briefly well-constructed graphic should have a title, figure, legend, and footnotes along with the figure. As with the tables, titles should contain words that describe the data succinctly and define symbols and lines used in legends clearly. One example of a diagrammatic method of presentation is through bar graphs. A bar chart or bar graph is a diagrammatic representation of data in quantities. It is a common statistical tool used for data categorization, and it often highlights the differences in the numerical values of specific groups of data. Typically, the data in a bar graph is represented using vertical or horizontal bars that are plotted in accordance with the statistical value of each data category. This means that the length or height of each bar is proportionately equivalent to the data that it represents. In some instances, a bar chart can be plotted in clusters to show more than one measured group of data. Typically, one axis of the graph details specific data categories while the other axis highlights the measured value for comparison. Here are the advantages and disadvantages of using the diagrammatic method of presentation. Number one is simplified data analysis. A bar graph simplifies the data analysis process by helping you to manage large volumes of data easily. Plotting your research data in a bar chart would allow you to easily compare, visualize, and comprehend different data variables at a glance. Next is it tracks data changes. Another advantage is for statistical analysis is that it helps you to map out and track data changes over a period of time. Unlike other statistical tools like a pie chart that can only represent one data set, a bar graph can be used to represent different data sets over a period of time. Another advantage is that it tracks organizational growth patterns. So a bar chart is extremely useful for tracking customer base growth or revenue generation patterns. Last is data comparisons. In addition, a bar chart aids in comparison across different sets of data because it clearly shows the relationship between each research variable and the fixed numerical value. However, there are also disadvantages. It cannot be used for qualitative analysis. Bar graphs cannot be used to represent research data gathered through qualitative observation methods. This is because a bar chart deals specifically with quantifiable data variables. That is, data sets that can be measured via numerical values. Next is complexity. Bar graphs can become extremely complex to understand, especially when dealing with large sets of data. Last is, it does not account for causative factors. So a bar chart does not account for any causative factors, key assumptions, or patterns responsible for the statistical variations in a research data sample. Data may also be presented using line graphs. A line graph is commonly used to display change over time as a series of data points connected by straight line segments on two axes. The line graph, therefore, helps to determine the relationship between two sets of values, with one data set always being dependent on the other set. Line graphs are drawn so that the independent data are on the horizontal y-axis and the dependent data are on the vertical y-axis. Line graphs are used to track changes over short and long periods of time. There is some debate about the degree of measurement between time points. Some say that the data must be measured nearly continually in order for the lines to be accurate representations. Others feel a monthly measurement is sufficient, even though the line implies data at points where no measurement was taken. Line graphs are also useful in that they show data variables and trends very clearly and can help to make predictions about the results of data not yet recorded. They can also be used to display several dependent variables against one independent variable. When comparing data sets, line graphs are only useful if the axes follow the same scales. Some experts recommend no more than 4 lines on a single graph. Any more than that, and it becomes difficult to interpret. Line graphs and scatter plots, like the one on the bottom left, are similar in that they record individual data values as marks on a graph. The difference between these two formats is how the line is created. In line graphs, the line is created by connecting each individual data point to show local changes. In this way, the local change from point to point can be seen. This is done when it is important to be able to see the local change between the pair of points. An overall trend can still be seen, but this trend is joined by the local trend between individual or groups of points, whereas the line of the scatter plot does not connect individual points, but instead shows trend followed by the data. Another way to present data is through a pie chart. It is sometimes called a circle chart. It is a way of summarizing a set of nominal data or displaying the different values of a given variable, let's say percentage distribution. This type of chart is a circle divided into a series of segments. Each segment represents a particular category. The area of each segment is the same proportion of a circle as the category is of the total data set. Pie chart usually shows the component parts of a whole. Sometimes you will see a segment of the drawing separated from the rest of the pie in order to emphasize an important piece of information. The use of the pie charts is quite popular as the circle provides a visual concept of the 100% or the whole. Pie charts are also one of the most commonly used charts because they are simple to use. But despite its popularity, pie charts should be used sparingly for two reasons. First, they are best used for displaying statistical information when there are no more than 6 components only. Otherwise, the resulting picture will be too complex to understand. Second, pie charts are not useful when the values of each component are too similar because it is difficult to see the differences between slice sizes. A pie chart uses percentages to compare information. Percentages are used because they are the easiest way to represent a whole. Some reminders on the use of graphics. Bar charts, either horizontal or column bars, are used to display categorical data. Strictly speaking, bar charts with continuous data should be drawn as histograms or line graphs. Usually, data presented in bar charts are better illustrated in tables unless there are important patterns or trends need to be emphasized. Avoid 3D graphs and charts. Three-dimensional graphics are impressive in slideshow and easily captures the attention of the audience. In medical writing, they are not effective because it is difficult to read the exact value on the y-axis, the height of the bars, accurately. Line graphs are most appropriate in tracking changing values between variables over a period of time and when the changing values are continuous data. Independent variables like time are usually on the x-axis, and dependent variables are usually on the y-axis. Pie charts should not be used often as any data in a pie chart is better represented in bar charts. If there are specific data trends to be emphasized, or simple text description if there are only few variables. A common error is presenting sex distribution of study subjects in a pie chart. It is simpler by just stating percent of male or female in text form. Research participants' identity in all illustrations, for example, pictures of the patients, X-ray films, and investigation results should remain confidential. Use initials instead of their real names. Cover or black out the eyes whenever possible. Obtain consent if pictures are used, and highlight and label areas in the illustration which need emphasis. Do not let readers search for details in the illustration which many or may result in misinterpretation. Remember, we write to avoid misunderstanding while maintaining clarity of data. Group data. It is the type of data which is classified into groups after collection. The raw data is categorized into various groups and a table is created. The primary purpose of the table is to show the data points occurring in each group. For instance, when a test is done and the results are the data in the scenario, and there are many ways to group this data. For example, the number of students that scored above 20 mark can be recorded. Ungrouped data. It is also known as the raw data that has not been placed in any group or category after collection. Data is categorized in numbers or characteristics. Therefore, the data which has not been put in any of the categories is ungrouped. For example, when conducting census and you want to analyze how many women above the age of 45 are in a particular area, you first need to know how many people reside in that area. The number of individuals residing in that area is ungrouped data or raw information because nothing has been categorized. We can therefore conclude that ungrouped data is used to show information on an individual member of a sample or a population. Some advantages of ungrouped data. Most people can easily interpret it. When the sample size is small, it is easy to calculate the mean and the median, and it does not require technical expertise to analyze it. Preference of grouped over ungrouped data. When collecting data, ungrouped data is preferred because the information is still in its original form. It has not been tampered with by classification or subdivision. However, analyzing it and drawing graphs, group data is preferred because it is simple to interpret. As to the accuracy of group data, so when calculating the means of grouped and ungrouped data, there will be a variation. The mean of ungrouped data may lead to wrong manipulation of the median, therefore it is considered inefficient in most cases. Representation of group data. Frequency tables are used to show the information of group data, whereas in the case of ungrouped data, the information appears like a big list of numbers. This is due to the fact that the information is still raw. Papers are often rejected because wrong statistical tests were used or were interpreted incorrectly. A simple approach is to consult the statistician early. Bearing in mind that most readers are not statisticians, the reporting of any statistical tests should aim to be understandable by the average audience but sufficiently rigorous to withstand the critique of experts. Simple statistics such as mean and standard deviation, median, normality testing is better reported in text. For example, age of Group A subjects was normally distributed with mean of 45.4 years old. More complicated statistical tests involving many variables are better illustrated in tables or graphs with their interpretation by text. Common mistakes in presenting data. Presenting data that has nothing to do with a research question. If the data does not have a role in answering the main aims of the study, then it should be ignored, even if a lot of time was spent collecting that particular set of data. Presenting only some of data. If you think you will want to draw conclusions from it or refer to the data in some supportive way, it must be presented. Using inappropriate and generic data presentation techniques. Selecting a data presentation technique simply from a drop-down menu in a computer-based spreadsheet shows lack of imagination, and there is danger that a poor selection will result in demonstrating a lack of understanding of the complexity of the data in question. Last is using a data presentation technique which is inappropriate for the data itself. Think carefully about the type of data, whether continuous or discrete, and whether the technique you have chosen is appropriate for that type of data. In addition, combining more than one data presentation together. Remember, the ultimate aim is to make the data, patterns, and relationships easy to see, not to create confusion for the reader. Presenting the same piece of data more than once. This can waste time and effort. Choose the most appropriate technique only. If that technique does not show everything you want it to, it is not the right technique to use. Lastly, using techniques in an inaccurate fashion. Spend time checking that you have labeled keys and access appropriately. Marks can be easily lost without these checks. That's the end of our group's report. Thank you.
So, is there any presenter pa po?